Okay, I wanted to pick up where I left off. I keep my videos to around 9 to 13 minutes, and I stopped my last one because I know with attention spans. And I was just kind of stopping on section 2B, I think it here. And if you recall, I kind of got out of order. I moved in the mapping section here on GIS, remote sensing, and maps. And I skipped a little bit by accident here, so I'll correct that here in a second. But the last thing we were talking about, and I had to come back to it because I couldn't resist not talking about global positioning and the evolution of the United States military to use a network of satellites. And using a network of satellites, we could build these handheld receivers you see here that actually could connect with those satellites, and using a series of triangulation calculations, they could actually tell you in seconds what your latitude and longitude is for any spot on the Earth. And you cannot underestimate the power of these receivers to create new jobs and careers, and obviously they're used on your cell phones, on your smartphones, and in your cars. The use of global positioning systems, I always tease students in class how I wish I could go back in time, and during the age of exploration with Columbus and Cortez and Magellan and Cook, I would have to think that this little device here could have been quite handy. But obviously, you're all users of GPS, and we do have a reading coming up on some videos. So I'm going to go ahead and close this out, and I want to get back to topographic maps. I think we're now back in order. We're on 2D, sensing and GIS, and that's off. And topographic maps are just another tool that geographers use, using lines to connect places of equal value. And I'm going to scroll down through here quickly as possible, and I'm going to try to give you a sample of a map. The United States Geologic Survey uses topographic maps to map every square inch of the United States, and they produce maps like this. And using these maps, these lines represent points of constant elevation. And when you see a map using ISO lines on a map, what we're often looking for is this map shows you the change in elevation across a section of land. And it's very helpful to understand where it's flat or steep, where the lines are very close together. That indicates a rapid change in elevation. And when you see the lines spread out, that's where you have a much slower change. Using these topographic maps, we often use them for surveying or understanding where there's places that are going to be likely be in floodplains or not, where there's likely to be wetlands, often maybe in low-lying flat areas where water's draining. So right over here, I could tell that this is a very steep embankment, and over here, this is more like a low-lying valley. And so this is the use of topographic maps, and I hope you see here that they're very powerful tools, and the United States Geologic Survey uses them to basically survey the entire United States. And this is how we often use surveyors, use them, and engineers to understand different objects and challenges on the lay of the land. Now we are on, I think I'm now moving on to Introduction to Remote Sensing. And Introduction to Remote Sensing this is some of the fun new technologies used when we study the Earth's environment, and we're trying to look at the four spheres that make up the Earth. The lithosphere, which is the crust; the biosphere is the living organisms on the planet, like plants and animals; hydrosphere is the water; and then the atmosphere are the gases around the Earth. Remote sensing is the use of elevated platforms like airplanes and satellites to point cameras down at the Earth and study the Earth from above. Using a variety of electromagnetic spectrum, we can look at the Earth now from cameras way beyond just what humans see in the visible light spectrum. Humans now have cameras that are set at different wavelengths that allow us to see the Earth in ways we never dreamed before. And it's through this examination that we can now study the Earth's crust, its water, its atmosphere, and its living organisms on the biosphere. And we could simply see things that we never could see before and study them using computers that are trained to look at these photographs and study pixel patterns from the cameras to identify trends on the landscape to identify, for example, using a remotely sensed image, we could actually calculate what percentage of this surface is covered by concrete, so we could address and model, for example, if it was to rain, how much water would soak into like surfaces like grass versus how much water would run off on impervious surfaces like concrete or asphalt, and that would increase runoff. And so remote sensing is going to be something that we talk about, and we've been doing it since the 1960s with the birth of the NASA program. And we'll have some exercises looking at satellite images, and here we're looking at satellite images to study weather. And you're looking at tropical hurricanes here off the coast of Mexico, and the ability to use these satellites to see where hurricanes are, how they're moving. We'll actually talk about the use of remote sensing and your mapping exercise that is shortly coming up. And here they just show you some different pictures that are being used to study the Earth. And when you're studying geography today, if you don't know how to use satellites, it would be like a doctor not using x-rays with like CAT scan or x-rays to study the human body. We simply could see things and observe patterns on the Earth that we could never do before. And I do have a video coming up shortly that I'll expect you to look at to learn more about remote sensing because it's so powerful. Geographers are using is one of the areas that I actually do quite a bit of work in, called geographic information systems. And you will be doing some work with GIS through very quickly in the mapping exercise. I expect you to read the evolution of this technology from the 1960s and 70s, but it's basically a marriage between the evolution of computer software and cartography, the science of map making. So reading here a little bit about the history of how we use computers to effectively use and to make maps and to update them and to analyze patterns on maps is absolutely essential. This diagram shows you effectively how we take computer hardware and software and we connect them with tools to actually understand and map the Earth inside of a computer digitally. And that's what GIS is. And the number of jobs that are being created with this technology is absolutely fascinating. So a number of you that are in business or in healthcare, I've read some of your career goals. You're going to be stunned of how many careers are using this technology. And if you're obviously thinking about the COVID-19 pandemic, it's the GIS software maps that are being used to update, you know, the frequency and the spread of the disease across the United States and globe for that matter. So here's a nice map, kind of combining a digital map that shows you a reference map showing you the outline of the continents and countries, and this is your reference map, and it is overlaid on top of it the location of earthquakes. And you can see that there's a very distinct pattern of where earthquakes are occurring along these straight lines. Now you're going to have to evaluate and understand why this pattern exists, and we actually do an exercise on this later in the semester, actually trying to evaluate and understand why these earthquakes are occurring where they do. Here's a map showing you the location and classification of the depth of the earthquakes being shallow and deep. So now we're not only just mapping where the earthquakes are occurring, we're showing you the depth of, and the depth of the earthquakes will actually influence potentially how strong they are and how they will be affecting the surface, where the black dots represent deeper earthquakes and the yellows and the reds are shallower earthquakes near the ground, in which obviously the shallower the earthquakes are going to be felt quicker and sooner, and you'd have less preparation time. And by using this GIS map, you can see that kind of like over the United States, we could see a lot of yellows and reds, which tells us we have a high frequency of shallow earthquakes, which would be very powerful for us to understand what this means, that we have a short response time for a lot of the earthquakes in the United States. We can make maps to also understand ecosystems and classify, using a GIS system to classify different types of habitats and where they are and what percentage of a land area is covered. And this would make us understand, for example, if I know the grizzly bear likes the mountain hemlock habitat on this map, I can calculate how many acres that species of bear is currently having currently survive. And if I can use this map and track it over time, I can see, is their habitat shrinking? Is their habitat expanding? And maybe that's why it's having pressure put on it over time, as its land use or its habitat that it survives on is being shrunk, often by humans expanding their human constructed environments into natural habitats of animals. I'm going to hit the back button. And I believe for chapter 2, and I'm right on time. The last thing I want to talk about is I'm so fascinated with maps, remote sensing, and GIS. I have a specific video on geospatial technology that you gotta watch this. You click on this link and you'll see a map open up or a page open up, and it was developed by Penn State. And I actually have it already opened here, so this is the way it looks. And you have episode 1, 3, and episode 4. I would absolutely episode 1 initially. And it's a 13-minute video segment, and it really goes into specifics of how remote sensing, GIS, and GPS are being used to transform how our world is being conducted today. And even though many of you are not geography majors, I think you'll be fascinated to learn how many fields and occupations are using GIS. So I'll let the video run here a second. And I'm going to go back to the beginning here. And here's the video starting. And I'm going to go ahead and hit stop. You can see the video's 13 minutes. Now, when you get back to the video segment, there are 4 videos, and I'd like you to read the first one, but episodes 2, 3, and 4 get into specific sectors. Like one of them is on law enforcement, one of them is how businesses and governments use GIS. And so, for example, I really like episode 4, which would tie into geography, which talks about how we talk about food production and agriculture and tracking diseases. I mean, are you kidding me? Look at the world we're living in. When we're talking about healthcare and food production and disease epidemiology, episode 4 is discussing how, like, the Center of Disease Control tracks disease outbreaks in Africa, and this couldn't be more timely for the class you're taking right now. Now, episodes 2, 3, and 4 are going to come up on your mapping lab that's coming up here shortly later in the week. And so, at least for now, just read episode 1 so you can get a better idea about GIS, remote sensing, and global positioning systems. And I could promise you the technologies are affecting you. And hopefully you'll see how they're affecting maybe even your own careers. So I'm going to go ahead and hit stop, and I'm right at my sweet spot, and I'll expect to hear back from you, and you let me know if these videos, we have about 2 videos, each of them's about 12 to 13 minutes, and I hope they help you understand what I wanted you to pick up from these chapters, this chapter here too.